So now that we've gone through factoring our different polynomials, we're now looking at factoring special cases. And there's certain patterns that are going to show up here. So if I have a squared plus 2ab plus b squared, or something in that form, this comes out to be a plus b squared, or just a plus b times a plus b. Same thing works if I have a subtraction out in front. It's going to be an a minus b squared, and that's on that middle term. Okay, so let's see what that looks like. So that's going to be something that looks like this, which is x squared minus 12x plus 36. So not so much getting caught in this rule. Let's think of what we would have done when we just factored this. I would have said, all right, I want to multiply to get to 36 that adds to negative 12. Well, the number that works there is negative 6 and negative 6. So we would have factored that to now be x minus 6, x minus 6, or you write that as x minus 6 squared. And what happened here is we had this 2 here. It turned out to be double the negative 6, which was the negative 12. So we could take out half of that value to work. Okay, let's look at another one. X squared plus 6x plus 9. I'm looking to multiply to 9. That adds to 6. 3 and 3 come to mind. So that's x plus 3, x plus 3, or x plus 3 squared. Well, what if we looked at x squared minus 14x plus 49? Multiply to 49, add to negative 14. Well, 49, I think of 7 and 7. But since this is negative, they both need to be negative. So it's x minus 7, or x minus 7 squared. So you're kind of seeing a trend here that it seems to be the same binomial repeated, or you write it squared for these examples. So now if we had v squared minus 10v plus 25, multiply to 25, that adds to negative 10. I'm thinking negative 5, so this is v minus 5, v minus 5, or v minus 5 squared. Okay, now we've added a little bit more to it. So now we have 4r squared, 36r, and 81. Well, the way we approached this earlier was we would have multiplied these two together, and that comes out to be 324. And then it has to add to 36. Now, we kind of already tried this. We made this here to be half of the number. So what if we tried like half of 36? Maybe 18 will work for us. So let's try this. Let's go 4r squared plus 18r plus 18r plus 81 and start to factor it. I can take out a 2r from the first two terms. That leaves me with 2r plus 9. I can take out a 9 from the second two terms, and that leaves me with a 2r plus 9. These match, so I get 2r plus 9, and the leftovers are 2r plus 9. And look, they're the exact same thing, 2r plus 9 and 2r plus 9, so that's 2r plus 9 squared. So I could still use that process we did last time to break it down, and I even use that half of it as a good hint. Now, if it didn't work, that would have meant 18 and 18 didn't work, and we'd have to go back and solve. What I also notice here is you see how 4r squared and 81 are perfect squares? If I took the square root of this, it's 2r, and the square root of 81, it's 9. It's just good to pay attention to when those come up, because they're going to give us a really good hint in how to solve it. So let's look at something like this. 100r squared minus 220r plus 121. Well, 100 and 121s are squares. Aren't they just 10r and 11? So maybe that is our final answer, 10r plus 11 and 10r plus 11. Well, let's try it out. So I multiply these two, and that gives me 12,100 by 100 times 121, and then the 220, which if we took half of 220 would be negative 110. Let's see what this looks like. So we got 100 r squared minus 110r minus 110r plus 121. I can take out, it looks like a 10r from this. I have 10r minus 11. These two are both multiples of 11, so I'm going to take out a negative 11, and I'm left with 10r minus 11, which we get to 10r minus 11 and 10r minus 11, or 10r minus 11 squared. So maybe it's a little bit cleaner if we start to recognize those perfect squares come up. Be careful, it's not going to be every time, but these perfect squares do help us. So now we have 25r squared plus 30r plus 9. You're going to use that as a hint. So this is 5r squared, and this is 3 squared. So maybe it comes out to be 5r plus 3 squared. Let's see what happens for us. 5 times 9 is 225. 30, if I want to add to 30, 30 is 15 and 15, which 15 squared is 225. So that's 25r squared plus 15r plus 15r plus 9. I'm going to take out a 5r. I'm left with 5r plus 3. I'm going to take out a 3. I'm left with 5r plus 3. And I get 5r plus 3 and 5r plus 3. So that's 5r plus 3 squared. 4x squared plus 20x plus 25. 4 times 5 is 100. I wanted to add to 20. Well, if I add to 20 get to 100, I'm going to do 10 and 10. So that's 4x squared plus 10x plus 10x plus 25. I'm going to take out a 2x and left with 2x plus 5. I'm going to take out a 5 and left with 2x plus 5. So our answer is 2x plus 5 and 2x plus 5, or 2x plus 5 squared. Okay, so now we shift to a different pattern, and this is what we're going to call difference of two squares. I have a squared minus b squared. Now this is different because it's only two terms. Here's an example of one we're going to look at in a second. So if this happens, we can split this to a minus b, a plus b. This is only going to occur when we see two terms. Okay, it's not an a squared plus something a plus b minus b squared. Only two terms, we're going to look for this. It's not every time. It does have to be subtraction and they have to be squares, but this is a convenient one that does come up. So z squared minus 9 is also z squared minus 3 squared. So if we did this rule that it says over here, that says this is going to become z minus 3, z plus 3, which is factored in our answer. Now, back to what we did earlier. Maybe this rule doesn't help us. This is like saying z squared plus 0z minus 9. So we need to find what adds to 0 that multiplies to negative 9. Well, the only thing that's going to work is when they're opposite numbers, negative 3 and positive 3. They add to 0 and multiply to negative 9. Let's look at another one and see if that works for us. So v squared minus 100 is, as we're saying, v squared plus 0v minus 100. Well, what adds to 0 that multiplies to 100? That's going to be negative 10 and positive 10. So our answer is v minus 10, v plus 10, which is also this number, minus 10, which is the square root of 100, and then plus. S squared minus 16. Get rid of the square root, so that's s. Square root of 16 is 4, and then s plus 4 is our other factor. W squared minus 144. We can take the square root of w. We can square the square root of 144. So it's w minus 12, w plus 12. M squared minus 225. The square root of 225 is 15. So that's going to be m minus 15, m plus 15. 16x squared minus 81. Okay, a little bit more to it now. Square root of 81 is 9 squared, or it's 9. 16x squared is really 4x squared. So I'm going to use these values and call this 4x minus 9. 4x plus 9 is my factored version. If we look at 81r squared minus 1, this is 9r squared. So my factors are 9r minus 1 and 9r plus 1. 9n squared minus 400 is going to be 3n squared. 400 is 20 squared, so that we're going to make 3n minus 20, 3n plus 20. Okay, now we have to kind of put it all together. We have a GCF, a greatest common factor, we have to look at before we can do this process. Now, one thing that indicates that is I have only two terms. I want to think difference of two squares, but these are not perfect squares. I can factor out. So anytime we can factor, we want to factor a number out, it's going to make the numbers smaller and it's going to make them nicer, especially when it's a difference of two squares. I can take a 6 out of both of these. So 6 comes out, I'm left with 4g squared minus 1. Which now is a difference of two squares. That's going to be 2g minus 1, 2g plus 1, bring down the 6, and it's our factored form. 12t squared minus 48. These are not perfect squares. It's a good hint then to look for a greatest common factor. In this case, it's 12. That leaves me with t squared minus 4. So that's going to come out to be a t minus 2, t plus 2. Now, maybe you looked at this problem a different way. What if we factored out a 3? That would then make it 4t squared minus 16, which still works as a difference of two squares. That would be 2t minus 4 and 2t plus 4. But the problem with that is it's not factored completely. It's not matching this. And that's because you can still factor out a 2 from each of them. So that would become 3 times 2, t minus 2, and then 2 outside, t plus 2. So this 3, 2, and 2 would then become the 12. T minus 2, t plus 2 become there. So even though it's a little bit different process, this is our ultimate goal. You got to get to this point. Okay, now we look at one like this. Maybe last time we would have gone through multiplied first and last term and tried to simplify it, but looking for the greatest common factor is going to make things easier. They're all divisible by 3. So now it's 4x squared plus 4x plus 1. Now I'm looking at ways to multiply to 4 that add to 4. So that's going to be 2 and 2. So I'm going to have 4x squared plus 2x plus 2x plus 1. Factor the first two, I can take a 2x out. I'm left with x plus 1, or 2x plus 1. I can factor out a 1 because I want it to match 2x plus 1, and I get 2x plus 1, 2x plus 1, don't forget the 3, and write it like this, or 3 times 2x plus 1 squared. Okay, a few more. First one, I can factor out a 3, and that's going to leave me with 9w squared minus 4. Now they're perfect squares. That works nicely for us. It's going to be 3 times 3w minus 2, 3w plus 2. 80g squared minus 45. It is two terms. I'm looking for a difference of two squares, but I cannot look at perfect squares with 80 and 45. So I'm going to factor out a 5. This is 16g squared minus 9, which suddenly looks a lot nicer. It's going to be 5 times 4g minus 3, 4g plus 3. Now 36w squared plus 60w plus 25. I could multiply these here. Maybe I can factor. Is there any factors we can find that helps us? Doesn't look like it. This is 3s and 2s. This is 5s. We have 5, and so nothing we can work with. So let's go 36 times 25. So we get 900, and it's got to add to 60. Well, 900 is 30 times 30, and that does add to 60. So let's go 36w squared plus 30w plus 30w plus 25 and see where that takes us. I can take a 6w out of the first two terms. Leaves me with 6w plus 5. I can take a 5 out of the next two terms, which is 6w plus 5. They match. That's a good sign. So we're going to go 6w plus 5 was the matching terms. We're left with 6w plus 5 as our other factor. They're the same thing, so we can write them squared.